Hey all, this is my final lab presentation on lab 5, which is to choose your own adventure. So for this lab, my adventure is to calculate the gravitational acceleration g by means of observing the motion of a simple pendulum. So the physics involved. First off, we have the formula for the period of the pendulum, which is given by t equals to 2 pi times root of L divided by g, where L refers to the length of the pendulum, g the gravitational acceleration, and t the period of the pendulum. So by using tracker, I've calculated the time taken for 10 oscillations. By doing so, I ensure accuracy of my results. So here's the video showing the 10 oscillations and the time it takes. As you can see from this graph, the graph shows a sinusoidal wave, which shows the oscillatory motion of the pendulum. We can also see that the distance at which it oscillates slowly decreases over time. This holds true as we can see that the energy would be dissipated from the system, not just in kinetic energy or in potential energy, but also in terms of thermal energy and sound energy. By looking at this table, we see the last recorded time of the 10th oscillation, which is at 11.248 seconds. Now, we will use this time and the total number of oscillations we counted and determine the time it takes for one oscillation, which moves from right to left to right again. So, by calculating the value of t, 11.248 divided by 10, we get the period of one oscillation, which is 1.124 seconds, round up to 3 significant figures. And L is 0.3 meters. Now, substituting the values into the formula we see here, we further simplify and calculate down, manipulating variables until we get g as the subject of our equation. 1.2 pi squared divided by 1.263 gives us an approximation of gravitational acceleration, which is 9.38 meters per second per second. As we can see, this is not as close to the real gravitational acceleration on Earth, which is 9.81 meters per second. The experimental value was off by 0.43 meters per second squared. However, there were sources of experimental error, such as when the pendulum was oscillating, it was actually oscillating in 2 dimensions rather than 1 dimension. Also, human reaction time was a source of experimental error. However, this is a very close estimate to the actual gravitational acceleration of Earth. Therefore, this experiment is successful to a very small extent. Thank you for watching my lab presentation.